8.2 properties of normal distribution. Okay, so we want to see what is the normal distribution. If you look at this shape, this is the normal distribution. In the middle one, we have the average, and we want to define the standard deviation. Let's just look at that. The standard deviation, we call it sigma. So if you're talking about from here to here is 1 sigma, right? Within 1 sigma, the area under the graph is that much, right? This area will be 68% of your data. Will be here. Within 2 standard deviation, mu minus 2 and mu plus 2, this is within 2 standard deviation. The area here or your data, 95% of data will be there. Is the area here going to be 95%? And within 3 standard deviation, the area here will be 99.7%. 99% is very close to 100%. Means most of your data or all of the data will approximately will be fitted into the 3 standard deviation. Now, here is the general equation for the normal distribution when the mu is the mean and sigma is the standard deviation. We call this one probability density is equal to 1 over sigma square root of 2 pi e to the power of negative 1 over 2 x minus mu over sigma power 2. So x minus mu over sigma is we call it z score. Okay. Let's just see what is the z score. Z score is x minus mu over sigma. We use that a lot. Yeah, pay attention to this example. It means normal probabilities. All that glitters is sparkly cosmetic powder and mechanical packaging. You put 50 grams of powder in each package. The actual masses have a normal distribution with the means. When I said with the means mu. The average is 50.5 grams. The standard deviation is sigma is equal to 0.6. The manufacturer wants to ensure that each package contains 49.5 grams of powder. What percent of package do not contain? So look at the standard, looking at the normal distribution. This is your normal distribution. In the middle, you have mu, right? It's 50.5 grams. We want to make sure it is going to be more than 49.5. 49.5 is on the left side, that is less than 50. So this number is going to be here, 49.5. The question said what percent of package do not contain this much powder? Means this is not acceptable, this area, right? Because this area is less than 49.5. It is less than what we expect. So I want to find this area. What you do, first thing we do, we convert 49.5, convert it to this z score. So z score is equal to x minus mu divided by sigma. So x here is 49.5. Minus mu is 50.5. By sigma 0.6. Basically, the score is how many standard deviation you are away from the mean value. If you do that, you get negative 1.67. Negative 1.67. What you get. So here you get negative 1.67. Of course, if you put the mu here, if you put that in this formula, this minus the mu is 0, right? This is 0. Now, the new things you have was the score. It's 0 here. Here you have negative 1.67. And you want to find this area. Make sure here is x. On the x-axis, you have x, your value in a gram. And here you have a z-score. You convert it, right? Now you want to see how we use the table to find this area. This is the table you have. See, the z-score is 1.67. First of all, these two pages on appendix is page 606. And 607 contain this data, which is the score. When you're using that, make sure this give you an area for a number. If you have a Z here, it gives you the area for the lower than that number, lower end. Now, the score is negative 1.6. So negative 1.6 is there, right? For the Z, see? It's negative 1.667. These numbers that you see, you just find 7. And you go down. So you see, I'm gonna make sure you get this. All right, so here is 0.6. Here is negative 1.6. See that? So this is negative 1.6. Oh, actually 7. I have to choose this. This will be. Negative 1.67. So the decimal of that, you find it here. So the answer is 0.047. The answer, this area here, little area, is 0.0475. This will give you that probability, right? If you want to do it with percentage, of course, you multiply it by 100. If you do that, it's going to be 4.75% chance that the packaging is less than 49.5 grams. Okay. Let's go back to this question. Yes, that would be the probability. I'm going to erase this. Okay, so here's another question. Standard test score to qualify for a special program at university. Someone hold the right standard at the test. Maximum score is 750 with the mean of that. So we have mean, mu, is 540. Standard deviation, sigma is equal to 70. That's only those who get above the third quarter, top 25% are admitted. If you get a score of 600, okay, let's just graph that. So this is the shape of this. In the middle, you have mu is equal to 540. The score that you get is 655. 655 is going to be above it, like that. Here, 655 is there. You want to see what the percentage here is. You want to see if you are in the top 25% or not. Again, you just convert this one to the Z score here. You know, Z is X minus mu divided by sigma. X is 655 divided by mu is 540. then it's 1.64. Now I'm going to the table again. So my z-score is 1.64. So here is the number negatives. I have put to next page. 164. Here's 1.6 here. I want to make sure you see that. It's 1.6, and you have to go all the way until you get to 64, right? 64. So this is the number. This is for the area less than that. This is for this area, which is probability when the x is less than 655. It is 0.9495. But I want to see what is this probability, right? Probability x greater than 655. Since total probability area is 1, it's just going to be 1 minus 0.9495. If you do that, I'm just approximate that to be 0.95. It would be 0.05, right? This area is 0.0. Of course, it would be really, really good score because 25% of your data, it's from here, let's say to here is 25% of the data, right? You just divide this one to the 4 pieces. Really, this is the top 5%. So you are in the top 5%, so which is much more better, top 25%. This person, of course, will pass this. Okay, so for this question, do the even question on these pages.